Conservation of mass. And this has nothing to do with being green or conserving water or anything. The law of conservation of mass says that matter is neither created nor destroyed in a chemical reaction. And this goes back to Antoine Lavoisier that we talked about the first day. He was burning things in closed containers. And he found that the mass of the container and its contents was the same before and after the burning. He was performing chemical changes on those substances, just like if you burn a log in the fireplace. That is a chemical change. But there was no new matter being created, and there was no matter that was being destroyed. In a nuclear reaction, you can have significant changes in mass. This is stated that matter is neither created nor destroyed in a chemical reaction. In a nuclear reaction, this is not true, but there are other laws that apply. But in a chemical reaction, any changes in mass are just so crazy small that we ignore them. The total amount of matter remains constant. So this is where thinking about matter or atoms as Lego blocks is helpful. So you build something out of Legos, right? Did you alter what the individual pieces were? No. And if you take that little structure apart and make something else using all the same pieces, it's going to have the same mass. In a chemical reaction, we're rearranging the atoms, but we're not actually creating new atoms or destroying atoms that were there at the beginning. It's just a matter of rearranging the atoms that were there. So if we took 58 grams of butane in that little cigarette lighter, we could measure how much oxygen it will react with. It'll react with 208 grams of oxygen, and it will form 176 grams of carbon dioxide and 90 grams of water. And we could say that more concisely this way. Butane plus oxygen, 58 grams of butane, 208 grams of oxygen. That's a total starting mass of 266 grams. We light that, it burns, it forms carbon dioxide and water. The total mass doesn't change. You still have the same number of carbon, hydrogen, and oxygen atoms. They've just been recombined into something else. This is an important idea. These questions with the math about conservation of mass tend to mess with students because they're actually at a very, very simple level, and most students completely overthink them. We're not into stoichiometry yet, okay? We're just at a very, very basic level here. Suppose 12 grams of natural gas combines with 48 grams of oxygen in a flame. The chemical change produces 33 grams of carbon dioxide and how many grams of water? You do not need to know any more chemistry than I have already told you about. Okay, we don't need to know the formulas for these things. We can just use words. So it might be helpful to just sort of draw a word picture here. So it's talking about natural gas and oxygen. Those are the two things that are combining. So natural gas plus oxygen. And they're undergoing a chemical change. And we're forming carbon dioxide and water. And we're told that there's 12 grams of the natural gas, and there's 48 grams of the oxygen, and it makes 33 grams of the carbon dioxide, and the question is, how many grams of water? Well, the total mass of the reactants has to equal the total mass of the products. So 12 plus 48 is 60. So we got a total 60 grams here, and over here we've got 33 grams plus X. We don't know. So 33 plus what equals 60? Well, take 60 and subtract 33, and you get 27. It must make 27 grams of water. So there could be a question like that on an exam. Don't freak out and try to do something complicated. Just what you start out with is what you end up with. It's just that the pieces have been rearranged. That's all. The mass doesn't change in a chemical reaction. Any questions?